So for this one, we have a related rates problem. So I have a laser pointed on a platform, rotating at 20 revolutions per minute, and the beam hits a wall 8 meters away, producing a dot of light moving horizontally along the wall. Let theta be the angle between the beam and the line through the platform, perpendicular to the wall. How fast is the dot moving when theta equals pi over 6? So the dot is right here. This is the red dot of the laser beam. And so what we can do is we can, what we want to figure out is how this distance x, which is from the laser beam to this perpendicular, how that distance x is changing for time. So how fast is the dot moving is we want to find dx dt. And we're given some information about theta. We know that it gives us a value for theta, and we know that the laser pointer is rotating at 20 revolutions per minute, and so that tells us that d theta dt is going to be 20 times 2 pi per minute. So that's 40 pi radians per minute. So 40 pi radians per minute. And what I want to do is find dx dt. So if I have d theta dt and I want to find dx dt, what I need to start with is the relationship between x and theta. And so what I can see is that I can see that tangent of theta is going to be x over 8. And so now that I have that relationship between theta and x, what I can do is take the derivative with respect to time. And if I take the derivative of that with respect to time, I'm going to get the derivative of tangent is secant squared of theta. And then by chain rule, I need to take the derivative of the inside part, the theta itself, with respect to t. So that's d theta dt. And then the derivative of 1/8 x with respect to t is going to be 1/8 dx dt, because the derivative of x with respect to t is dx dt. And so now I'm ready to plug in the values that I know and solve for dx dt. So I'm going to get secant squared of the theta that I was given was pi over 6. So So I can do secant of pi over 6, that whole thing squared, times d theta dt, which is 40 pi, is equal to, and I can multiply the 8 over, and that's going to be dx dt. So that tells me dx dt is approximately, so when I type this in my calculator, I'm going to do 8 times, and then I'll do 1 over cosine of pi over 6, that whole thing squared, times 40 pi. And so if I do all of that, I get 1,340.41, and the units of that are, x was measured in meters per minute. T was measured in minutes because I was given that my revolutions were in revolutions per minute. So it's that many meters per minute. On B, it says a car travels down a highway at 25 meters per second. An observer stands 150 meters away from the highway. So we can have the highway and we have the observer here. And we know that that distance is 150 meters. And that makes a right angle there. We want to talk about the shortest distance between that observer and the highway is 150. How fast is the distance from the observer to the car increasing 6 seconds after the car passes in front of the observer? So the car is here. And so then it asks how fast is the distance between the observer and the car changing? So we'll label this guy Y. 6 seconds after the car passes in front of the observer. And so if the car is traveling at 25 meters per second, so we want to find dy dt when and then we'll call this guy, maybe we'll call this guy X. X equals, let's see, 6 seconds. So 6 times 25, 150 meters, given that dx dt is equal to 25 meters per second. Okay, so what I need is a relationship between y and x here. And so if I look at this function, or if I look at this triangle, I have a right triangle. So I know that x squared plus 150 squared is equal to y squared. And so I can take the derivative of that with respect to t. And so I'll get 2x dx dt plus derivative of 150 squared is 0 equals 2y dy dt. Okay. And so then I can plug in everything I know. I know a value of x, I know dx dt, I want to solve for dy dt, but I need the value of y that works when x is 150 meters. So if I have y squared equals 150 squared plus 150 squared, that gives me y is equal to, so I'll get 2 times 150 squared, and we'll do the square root of that, which is going to be 150 times the square root of 2. And so I can plug all of those things in. So I'll have 2 times 150 times dx dt was 25. It's going to be equal to 2 times 150 square root of 2 dy dt. And so I can solve that, and I get dy dt is equal to, I can divide both sides by 2, I can divide both sides by 150. I'm going to get 25 divided by square root of 2. I get 17.6. And the units for that are the same units as dx dt, which is meters per second.